by Adam Ruskin, our technical excellence lead for food safety, as well as for Stephanie Kitts, our technical excellence team for food protein. Both experienced colleagues with a lot of practical knowledge from the field. And I am Sandra Sau, care of marketing segment protein. I will run you through as a moderator through this webinar. So have a good time, and thanks, Ed, to get us started.
Great. Well, thank you very much for the introduction, Sandra. So just if you guys couldn't hear quickly, we'll put the Q&A in the chat, and then we'll take the questions at the end. So without further ado, let's start. So I always like to start with a food safety moment since we're a food safety group. And I thought that something interesting to discuss today for our food safety moment is how DNA can actually help solve issues. So when we're talking about DNA and food products, generally we're talking about whole genome sequencing and the sequences the authorities are using to connect infections in people and foodborne illnesses with plants and products to really quickly define where a contamination is coming from. It can also help define recalls and many other things. So it can be a very, very powerful tool. On the other side, which I think people often forget, is how we can use DNA in the facilities to also identify root causes, make connections between the contaminations that you're finding and potential other outbreaks in the market, or just making the connection between cross-contamination factors to help you figure out where it actually came from. A nice example of this could be as part of your environmental management program, if you're doing whole genome sequencing, if you find Listeria in a close or zone 2, then what you can do is you can do the serial typing, and maybe you found it in also outside of the facility or in a truck loading bay. And then this will help make the connection that you need to work on your environmental management program, for example. Or you can also use it in the same way if you have raw materials coming in, you're doing the frequent testing, and you have the sequencing related to the microorganisms. Then if it makes it into the product, you can also tell whether your kill step is functional or not. So, you know, often from a food facility standpoint, we're thinking about whole genome sequencing and this stereotyping as a, you know, a little bit of a threat in certain cases, but in the other hand, we can also think about it in a way of how we can use it at the production site to really connect data points and get back to the issues at hand. So hopefully that food safety moment makes sense for everyone, and hopefully also it'll connect a little bit to the rest of the discussion. So today what we'll plan on talking about is Listeria prevention by environmental management and open plant cleaning. So the focus today is a little bit more on Listeria, but the same thing also applies to yeast and mold or salmonella in the manufacturing environment as well. So let's talk about why Listeria is a big threat. So the first thing is, where does it grow? It really grows in a very wide range of conditions. It can grow from a low pH to a high pH. The water activity can be very low as well, and it's very temperature tolerant. You know, we've seen in recent cases the contamination of the ice cream. So more and more we're finding that Listeria can grow in a wide range of growth conditions. From the consumer standpoint, it has the highest death rate of all of the foodborne pathogens, with about 97% hospitalization and a 13% fatality rate. So in terms of its ability to survive in the food products and its ability to actually infect and kill people is really important to consider. And this is one of the reasons also that testing your way out of a problem isn't necessarily the best solution. So what we're here to talk about today is how you can combine open plant cleaning and environmental management to help manage and mitigate any risks, or most of the risks, related to Listeria in the environment. So what we'll start with today is environmental management. So let's talk a little bit about what environmental management is. Environmental management and the programs associated with it are intended to help mitigate risks of cross-contaminations of microorganisms from the harborage zones, so in air ducts, on the floors, in the drains, in hard-to-reach pieces of the equipment, and the food products. We also have the environmental monitoring programs, which basically monitors the effectiveness of our cross-contamination measures. So these two programs obviously work hand in hand, and they're very closely related. The next program that we wanted to discuss was open plant cleaning. Open plant cleaning is about how do we clean the facility and make sure that the facility and the open equipment are in a status where we are happy with the microbiological load, the organic residue load, any allergens, physical debris, or other hazards that potentially could be there. Really, the goal of the open plant cleaning program is to reduce the microbiological load on all of these surfaces so that there aren't problems down the line as we're producing the food products. So very quickly in summary, basically you have open plant cleaning, which is intended on keeping the area clean using the right amount of resources based on your desired outcome. And by desired outcome, we mean related to the quantity of Listeria, the quantity of yeast and mold, and those types of things. The second part is really about cross-contamination. Cross-contamination is about ensuring that we're not moving these microorganisms like Listeria, yeast and mold, other things around the facility. So we might ask ourselves, okay, why is this important? So really, we have the environmental management program, and it's about generating data and stopping the spread of microorganisms around the facility. We can do this through these different cross-contamination management measures. So foot baths, hand washing, the potentially decontamination of the air in the air handling system, and things like that. Then we have the monitoring programs, which are really about how do we test in the facility for any potential pathogens, indicator organisms, and actually demonstrate the management program of environmental management is actually effective. So if we're starting to find Listeria transferring from some of the harborage locations via people's hands or the cleaning tools, then this monitoring program will help us generate the data to say, okay, we need to do training, we need to work on the topics, we need to do something different in order to better manage the spread of microorganisms around the facility. Then we look at open plant cleaning. Again, it's about preventing the microorganisms from establishing harborage locations in the facility. So if we look at really the goals, it's about removing growth factors, destroying these niche and biofilms that could potentially be developing in the open plant environment. So as we look at, what are the effective steps of cleaning, that's really the important part to keep in your back of your mind and identify how do we manage these things slightly differently. So now we'll dive into a little bit more about environmental management programs.
Okay, thanks, Adam. So if we can just go on to the next slide. I just want everyone to take a look at this. Anyone who is in the factory environment every day, and look at this picture. This is your factory potentially. So there are lots of different points of contact here. There are lots of different areas, lots of different zones, lots of different production processes, people coming in and out. I mean, this looks like a crazy diagram, but this is potentially your factory. And if we can just think about, have you ever, I like to draw this comparison. Have you ever looked at your hand and noticed that there's an ink stain on your hand, and you go, I wonder where that came from? I don't remember touching anything that had ink leaking from it. I mean, I draw a parallel on that. Listeria is not that different. The only difference is you can't see Listeria. So you could have touched many surfaces that has Listeria on it and transferred it to many surfaces, but you don't know. If you haven't washed your hands, haven't used correct hygiene procedures, you don't know it's there because you can't see it until you test for it. So it's difficult to imagine a completely free from Listeria factory, okay? So the key to it really is managing it. And the reason that it's very difficult to achieve a complete free from Listeria factory is because there are so many different vectors and so many different people that enter the factory that maybe don't always wash their hands, they don't use the proper boot wash procedures. You're bringing in ingredients, you're bringing in packaging, you're bringing in so many different things that are difficult to control. So it's really the environmental management. Management is the key word here. It's to ultimately manage the cross-contamination. So all the different parts that you can see on this diagram, to try and control them and manage them to the best that you can. It's interesting because I did a project a number of years ago where we took, I think it was about 300 swabs post-clean. Okay, so the hygiene process was super effective. The chemicals, the methodology, everything was great. We got clear swabs, completely clear. We then took the same swabs 12 hours into production, 24 hours before the next clean, and you could actually see a path of where the Listeria was being transferred. So it is quite incredible, very easy to transfer, but also quite easy to manage and control. What we would say is the first step really is to make I suppose a cross-contamination map, which won't look that different to the picture that you see on the screen, and think about and look at how possibly microorganisms, not just Listeria, but general microorganisms and pathogens can be moved around. Think about people moving, where people move during production, maintenance people coming in and out all day long. Water, are you using water during production? If you are, you're increasing your risk of Listeria transfer. Is there aerosol produced if you're doing any hosing? In a high risk area, you shouldn't be using water during production anyway. But it sometimes it is necessary. Wheels, anything that transports or moves around the factory can also transport Listeria on the wheels. Anything that's coming in from the outside, packaging, ingredients, even the actual product itself. So it's really important to think really open-minded about where contamination can come from. And then it's really looking at the map of the facility and looking at the normal activities. Look at all the possible ways that microorganisms can move around, and even think of I suppose, less likely paths. So we've got to think outside the box here. You know, some can appear to come out of nowhere, but there's always a reason for it. You know, Listeria doesn't appear out of nowhere. It has to come from somewhere. And really the key steps in this process is to look at identification and segregation of your risk areas and the possible hazards associated with those, and then the zoning plan. So zoning can be done in there are two different ways really of thinking of this. You can have hygiene zones, which you will see in, I suppose, the one that everyone would know is BRC, where we've got high risk, then high care, ambient high care, low risk, and then enclosed and non-product areas. Or we've got sanitary zones, which can pretty much mean how close does the food come to those zones. So we've got general zones. Is it close proximity? Is it indirect food contact, or is it direct food contact? Direct food contact obviously being the most key and the most critical. Okay, thanks, Adam. Go on. Okay, so let's not forget about entrance zones, okay, because you know, there's quite a variety of boot washers out there and different ways of entering a factory, and boots and hands are going to be very critical here, because boots can transfer Listeria very, very easily if there isn't good boot hygiene in place. And there is absolutely no point in having a boot washer if it is not maintained well and cleaned well and kept in good working order with chemistry, the correct chemistry going through the boot wash. Because in my 20 years doing this, I've seen some quite shocking boot washers, and they actually make the problem worse. So boots that were clean going into them walk out of the boot washer worse because they're being contaminated going through it, and then they transfer Listeria and other pathogens through the whole factory. So it's really important. It's important to get it into people's heads why their boots need to be clean when they enter a factory, why their hands need to be washed and disinfected every time they enter a factory. If you have glove chain, if you use gloves for production, it's important they understand the process of why they're doing it. So hand hygiene is really critical. It's important that we have the correct hand washing and disinfection stations in the right place to manage the risks. And people absolutely need to be aware of why they have to wash and disinfect their hands. It's important that, to me, certainly where this has been more successful, where I have seen this being a success, is where people truly understand the food safety culture. So we know in a lot of factories, and especially in your factories, you will have probably quite a large turnover of staff. You may have new people starting every week or every month, but it really is so important at the very start in their induction why it's so critical for them not to do crazy procedures during production, like lifting drain covers, like touching the floor, then touching surfaces. You know, it's almost a bit of it's a true education for them. And if they understand the food safety culture, it becomes embedded in the company and in the business. Thanks, Adam. Next one. Cleaning tools. So this is an interesting one for me, because we see cleaning tools obviously during the main hygiene process at night time, the open plant cleaning process. And we also see a lot of different tools and utensils used during production time when we are trying to prevent cross-contamination. So brushes, and I include actually squeegees in this as well. Brushes are great. They're very good at removing soil from surfaces. However, they're only as good as the hygiene procedure for those brushes is. Squeegees too is another good example where I've seen some really interesting cases of squeegees used. So if they're damaged, if they're broken, the foam type squeegees, which interestingly are still used in the food industry, they're key harbourage points and harbourage areas for pathogens like Listeria. It can be easy to forget the hoses or the guns or the nozzles or the cleaning equipment that's used. They must be cleaned as well, or all you're going to do is cross-contaminate. So the picture of the cleaner, scrubber, dryer, if it's not clean, if you don't clean it when you've used it, the next time you use it, it will just transfer microorganisms across the place. They can be very difficult to clean and complex pieces of equipment, but it is so important that there's a hygiene regime built in there. It's important that things like brushes or squeegees are cleaned well, and that's really key. Also, I think it's important that they should be numbered or identified in some way, so that they go through a proper hygiene process, so that it's not the same brush and squeegee being cleaned every day after production. If you have 100 of them, it's important that you register somehow that each of those 100 were cleaned effectively. It's important that we have preventative maintenance as well in items like vacuum cleaners, cleaner and scrubber dryers, just to be sure that they're always working at their best, that they're not going to cause issues. If they fall into any sort of disrepair, it's really difficult to get them back to the original standard that they were at. Vacuum cleaner follow the same sort of pattern. If you can imagine, if you're using a vacuum to suck up often wet or dry residue, if that residue had been contaminated with any pathogens such as Listeria, it's now going to be inside that vacuum. So it's very important that these are cleaned and maintained in the proper manner. And just one last point on the hoses. I've seen quite a lot in factories where people have been using hoses and the hose is on the floor, obviously where it should be, and then it's moved up and dragged over the top of a conveyor belt, for example, which has been cleaned. So all the contamination that's potentially on that floor is now on top of the clean conveyor belt. So it's just important to think about the cleaning tools and how they're managed. Any damaged or cracked hoses must be registered with the maintenance team to make sure that they're repaired or replaced. Okay, thank you, Adam. And pressure cleaning. So this is quite an important one for both for water usage and actually for food safety, which is the most key factor here. It's important that we use the correct water pressure and the correct nozzle type as well. So we've got on this graph, it shows you different types of water pressure. We've got low pressure, medium pressure, and high pressure. When you're using very low pressure water, so sort of 3 to 7 bar, it's very high water consumption, and it doesn't really remove the soil that you want it to remove. When you go up to the other end of the scale, where we've got very high pressure, and we've seen this time and again in the industry, it's very strong aerosol formation, and all it tends to do is move pieces of debris and soil from one piece of equipment onto the next. And I've watched people hosing where they've hosed the conveyor belt, and then with high pressure, it is now on the wall beside the conveyor belt, and then back to the wall to hose it off the wall, and it's back onto the conveyor belt. So it's really just, you know, high pressure has its uses in some areas, but certainly not for high risk food factories. Because of the aerosol, we know Listeria doesn't just hang about in the air, but it will be transferred in the air if it has a vector such as water droplets or aerosol. So we try to keep the aerosol down to a minimum. So the perfect pressure is sort of 7 to 25 bar. And we would class that as medium pressure, and it gives the best balance between water droplet generation and cleaning force. Because I've dealt with people in the past who are reluctant to move from high pressure because it gives such, it removes debris so effectively off the equipment, and then they move to medium pressure and it's very, oh, this is never going to work, it's never going to be as effective. But actually it is. 25 bar is more than enough to remove debris and soil from the surface. Okay, thanks, Adam. And then just this last slide is, you know, don't forget the air. As we've said, Listeria doesn't just live in the air by itself, okay? It needs something to be transported in the air from. So it can be aerosol, water droplets. That's why we suggest you don't use water during production times, especially in high-risk factories. But if you're cleaning and they're on your main hygiene process and there's a lot of aerosol formed, think about where that's going. So is it going up into the air handling units, into the ventilation shafts, into the fans, into the condensate drop trays? We got to think about where it potentially could be going. So always something I always do when I go into a factory. I always look up to see what's up there, what's the air handling, air socks, lots of sources for contamination, which people often forget. So you must build in these pieces and these areas as part of a deep clean and environmental management program. So don't forget about them, because once you've got contamination up there in these systems, it's just a matter of turning them back on. So you've done a perfect job underneath. Your factory is complete. All your swabs are clear after you're clean. And then you turn on the air handling system or the fans or whatever type of system you have for managing your air. And suddenly you could have Listeria right back across your whole factory again. So that's why, you know, we've just said here, don't forget the air. Even drips, any drips that you see coming down from here could be contamination risks as well. You know, even condensation that forms on the ceiling has got to be considered. If you have heavy condensation after a clean, you've got to consider a way of removing this effectively and then disinfecting the ceiling and equipment below. So it just depends. Some factories don't have a condensation issue because they have super extraction. It just depends on how low the ceilings are and so on. But always look up would be my guide at the end of this slide. Okay, I'll hand back over to Adam now.
Great, thanks, Deb. So now that we understand a little bit about environmental management and how that plays a role, let's talk about open plant cleaning and really the importance of that. So open plant cleaning is often a very time-consuming process, but there are kind of three key parts of it that are often kind of forgotten and missed. The first one is really about using validated cleaning procedures. The second is making sure that you have the right cleaning tools and the right solutions to conduct your open plant cleaning program. And then the third one is really about how are you monitoring and verifying the activities were successful or not. So if we think about OPC, or open plant cleaning validation, there's a few different things that come to mind. More and more, the audit programs from GFSI are putting extra emphasis on open plant cleaning and the validation that's behind making sure that you have an effective cleaning program. Also, we're finding more and more that having a strong open plant cleaning program can help manage the risks after you've done your environmental management. So if we think about the audit side of it, it's starting to become more and more important. Then the second part is that it's really adding an extra layer of defense around the product. So the situation ends up being that you've done your cleaning, and inside your filler through CIP or cleaning of the surfaces. And so now your barrier of defense is just around the product. But if you slowly move out from there and you have a strong environment or open plant cleaning program, then you'll start to build these extra layers of defense, and it'll take longer for any potential contamination to reach the product. So as we talk about having a validated open plant cleaning process, we might ask ourselves, what are some of the minimum things that should be considered and looked at? So for me, always the first thing to discuss is it hygienically designed and cleanable? The reason that this is super important is because if it is not hygienically designed, then you need another compensating factor. This could be disassembling the equipment, could be more cleaning time, or more resources or different chemicals to make sure that you'll be successful. And so this will come out in your methodology part of the validation process. The next part is really about ongoing assessments. How are you assessing whether your program is still at the validation criteria that you set initially? Has the product changed? Have the chemicals changed? Has the environment changed? Has the equipment changed? These types of things. The next part is really about defining expected outcomes. I think a lot of places, and Steph mentioned this very nicely, people want to set 0 Listeria targets, but that's often very difficult. So it's really about figuring out how to manage and prevent and keep the frequency to a level that matches your expected outcome. So at some point you might decide, okay, I'm happy with 10 CFUs per 10 centimeters squared or some expectation, but whatever it is, it does need to be defined so that if you do have a positive, you can say concretely, yes, we agreed that this was within or not within our defined expectations. The next part is really about what are the monitoring points and how are you actually doing the verification related to your open plant cleaning program. Because often the open plant cleaning validation is different than your environmental monitoring. If you think about the example that Steph had given, when you do your environmental monitoring, it's not necessarily right after cleaning, because theoretically, if you're doing a good job of cleaning and you're validating your clean was effective, that'll be right after or thereabouts. But if you're trying to look at your cross-contamination vectors through your environmental monitoring, they should be at a time period after. So they are actually 2 separate types of verification. And then the last part is really related to continuous improvement activities. These continuous improvement activities should always be part of your validation process. So after a year of doing your validation, what did you learn from your assessment and how did you put that back into your validation and improve the process? So before really diving into actually executing a validation, there's a few things that really should be considered. When we're defining our plan and what we want to do, again, we need to think about what are our expected outcomes? What do we want to achieve? Is it 1%? Is it 5%? And there needs to be a decision made around what is your expected outcome and potential contamination level. The next part is really about what are the best methodologies and methods for cleaning. Is it going to involve more mechanical action? Is it more foaming? What are the different materials that are in place so that you can choose the correct methods? After, there's also a challenge of getting back to baseline. So what I mean is related to the preventative maintenance of the equipment. Often there's damaged floor tiles, there's damaged equipment, somebody hit the piece of equipment with a fork truck and now the panel's a little bit bent and it's leaking water into the inside of an electrical cabinet or something like that. So it's really critical to have this assessment and go through and make sure that the equipment is actually at the OEM standard. Depending upon the age of the equipment, the OEM standard might have been slightly different as well in relation to hygienic design. At some point, we've advanced the expectations of the microbiological criteria of the finished product. So at some point, that also changes the way that we need to expect the cleaning and the hygienic design to work. So making sure that we're meeting the current hygienic design standards is also really critical. The next part is really about linking the plant programs. So how are our validation programs linked with preventative maintenance? Are we documenting what the preventative maintenance program is in our validation? So an example of this might be related to gaskets or rubber pieces in the food facility. If we have a 6-month preventative maintenance program for these rubber gaskets and we do our validation, then we're at that one point. But if we change our preventative maintenance program to a yearly, and we continue the same program of cleaning and sanitation, at some point the chemicals might start to affect these gaskets, and this needs to be considered in the preventative maintenance programs. The next part is really related to having the right cleaning equipment in the right places. So in order for people to be successful in their cleaning operation, they need to have good functional equipment, and it needs to be in the right place. So if we go back to Steph's example with the hoses, we don't want people draping the hoses that were on the floor over conveyors, or maybe the hoses are too short. So at some point, we need to make sure that we have the right cleaning in the right places. The next part is really related to having the right digital tools, or at least SPC tools, to track the progress of your programs, to be able to look at the trends and make sure that everything is in the right place, we're using the right concentration of the chemicals, we're achieving the outcomes that we want to achieve. So all of these things need to be considered and done as pre-work before we actually dive into the validation. After we've considered all of these things and all of these things have been reviewed, they can all be documented for the validation as part of the pre-work. And then you can start to dive into actually building the validation and the execution, documenting the process and really understanding how all of the pieces work together. Another example of why it's really critical to choose the right cleaning method is related to how well the different cleaning chemicals work on different food products. So here's an example where you took a chlorinated product and you put it on this egg protein. You can see that you had the untreated surface, which was kind of the starting. After 5 minutes, 10 minutes, 15 minutes, you put this chlorinated product on there, and at the end, you really weren't very effective. Versus this other product that was really the validated chemical for the product, it is gone in less than 5 minutes, and the surface is clean. So this is a prime example also of why having a validated cleaning method is really important. It can set you up for success and demonstrate why maybe you need to use this chemical versus another chemical or something like that. So at some point, it's really critical that having this documented, validated methodology is really important. It also provides information to show why you chose a chemical, so that if down the road you want to change chemicals, then you have a documented process about why this was chosen, what it was effective against, and how. And it will set you up for the future if you start to change products or you start to change chemicals, and to have that rationale of why you're at the particular place you are today. Next, often when we think about validation, there's a lot of pain points. And doing validation is never easy, but it's really critical in order to make sure that you'll be successful. As we think about different areas in the food facility, we have hard to clean areas, or we have places where there's rubber guards or overlap with conveyors, rough floors, and these types of situations where they could be improved. These situations end up putting the cleaners and the people doing the actual cleaning in a very tough place, because there's pressure to not overuse resources, do it quickly so that we can get the production equipment up and running as quickly as possible. But these types of situations make it really difficult for them to actually be successful. So as we're starting to think about, what do we need to do to be successful, these are some of the basic things that should be considered to make sure that what we're asking people to do, they can actually execute and be successful. The next part is really about some of the equipment parts. As we're looking at, access, how was the actual equipment set up? Do we have hygienically designed feet? Do we have bad wells which can actually harbor bacteria, soils, and create these harbor zones? And then also, it's always hard to clean on top of the pipes, but if we have a pipe, there can be condensation on the pipe, and we have a bunch of dust on the pipe, which could potentially be a harbor zone. Now the condensation is growing, and we're creating an environment where bacteria can start to grow. So you have food, you have water, and then all you need is a few drips on some product surfaces. You have an overlap in the conveyor that doesn't necessarily get cleaned very well. And now you start to have this kind of connected web of potential cross-contamination points, along with open plant cleaning programs that'll struggle to be successful. The next part to also consider is the center circle, or the time, temperature, concentration, and mechanical action that's required. These types of things are also really important. A lot of times when we're applying foam or we're applying a disinfectant, we're not giving it the amount of time that it needs to actually have the effects that we want. So making sure that we have the right time, temperature, and concentration are really important. Especially with foam, the mechanical action part of it is related to the bubbles and how the bubbles are formed and the popping of the bubbles. So if we have dry foam or wet foam, we can be in a situation where we don't actually have the best situation to be successful. So it's really important to consider those things. Again, with high pressure, it is very good for removing soil and debris, but we also need to make sure we're considering the cross-contamination risk and moving things around the facility. As Steph said, you can spray it off of the floor, but then now it's on the wall. Now you need to spray the wall. And so you can really lose a lot of resources by going back and forth. The next thing is cleaning frequency. Determining the right cleaning frequency is often a real struggle. The reason is because it's often just based on the production frequency or the amount of uptime that's expected. But we also need to consider cleaning frequency from the product standpoint. So if you think about connecting the product expectations for the microbiological load, how quickly that product can either grow or support the growth of a set of microorganisms, that will help you actually dictate a realistic cleaning frequency. In a lot of cases, we find that the microorganisms and biofilms actually grow really quickly. So if you've set a 2-week cleaning frequency based on resources or production schedule, then that might actually be too long, and you're going to actually end up struggling more, which will then take longer because now you have the product that's dried. You need to scrub harder. You need to let the chemicals sit longer for them to actually work. So in some cases, cleaning frequency can be reduced, but your cleaning time can be shortened as well. So really finding the right balance of cleaning frequency is critical. When we think about monitoring and verification, there's a few different things that we need to consider. There's different levels of monitoring and different ways that we can accomplish it. So we can have monitoring, which can be data-driven. We can be collecting time, temperature, concentration data of the foaming nozzles. It can also be ATP and those types of things. And it's really important to have the trends to prove your cleanliness and your effectiveness of your cleaning. The next part really is about the verification. From a verification standpoint, you can do many different things. You can have a visual check, you can have a smell check, which is slightly objective, but you can do it. You can use the UV lights to really show how effective your cleaning was and highlight different things. You can also have ATP and microbiological swabs as well. The most important thing out of all of these is that you document the results, because if you didn't document it, then it never actually happened when an auditor comes through. The next important part is really linking your programs to food safety culture. So in the end, as we're talking about why we need to do it and how it links to food safety culture, we have validation, which is really the proof that something can be successful. So if you're talking to the cleaning forces and the people who are doing the cleaning, here's the validation data that actually shows you that cleaning is possible. After that, we have monitoring, which tracks the progress. It's showing on a graph, on a piece of paper, visually, what is the progress of it. And then we have verification, which is the confirmation that we were actually successful in meeting our key performance indicators. And overall, these things will help combine to drive engagement, ensuring understanding about how the cleaning process is working. It'll also expand people's knowledge. If people understand more about the cleaning process, they will be much more inclined to actually execute it. And last, it'll also link to continuous improvement, because now that more people are engaged in the cleaning process, they can help propose new solutions. They can start a discussion around a product and the way to clean better. Maybe they have some ideas. The next important point is that often the cleaning programs are crossing. So what I mean by this is when you have an open plant cleaning process, you're targeting the removal of harborage locations. But on the other side, you could have a situation where your open plant cleaning program is actually negatively impacting your environmental management program. So an example of this, again, is that high pressure hose. You know, from an environmental management stand program, you're spreading aerosols around the facility, you're making problems for your environmental management program. But it's a very effective open plant cleaning tool. So when you're going through and you're looking at the different situations, you also need to consider this. It's the same for your environmental management program control measures. You can have a foot bath, which is a great control measure for Listeria in the food facility. But if you're not cleaning it, if you're not maintaining it, if you're not cleaning under these grates that are before and after the foot bath, these can then become harborage locations and actually make your environmental program not only a cross-contamination point, but a point that's really dirty and difficult to clean. So as you're looking at the two programs, it's really critical to make sure that they are working together and that each one of the programs has considered the other. So in conclusion, as we get to the end, there's three kind of key core points to take out of this. The first one being the interconnection of the open plant cleaning process and environmental management. These 2 points are very closely linked from a verification activity standpoint. You know, when you test, where you test, how you test. You can often test for Listeria. And if you want your open plant cleaning process to be effective against that, and you can also test it if you want to look for cross-contamination with the environment. So really, these programs are very interconnected, but they're also very different and they're separate. The next part is really about environmental management and management of cross-contamination. We need to consider all of the different pathways that cross-contamination can be present. And often this is a very good place to start with for managing Listeria. For the primary reason, it's really hard to control Listeria if it's constantly moving around the facility. If you clean one place, then it can just transfer to a different one. So really the cross-contamination management and environmental management is critical. The last point is about using a validated open plant cleaning program. These validated programs will help drive additional engagement with the cleaners, with the people who are responsible for the production, and also help set a precedent in the facility. If the facility is nice and clean and sparkling, people will also take much more respect into the facility. So that is what we have. So thank you for listening. Do we have some questions?
We've got a couple of questions. Thank you, first of all, Adam and Stephanie, for sharing your information with us. And just a quick information. So there were some participants who might have had difficulties with the sound. The session has been recorded and is going to be shared, so you can repeat it for the topics of interest. So we've got a couple of questions, and I will assign them to our experts here. So one of those was cross-contamination can happen via air and aerosols. So what could be an effective measure to get this under control, and is fogging a method to address this? Stephanie, I will hand that over to you.
Okay, thanks. Thanks, Sandra. So, I mean, as I mentioned, yes, aerosol absolutely is a vector for transferring Listeria. It doesn't just travel about on its own without something to travel in or connected to. So, I mean, fogging is certainly an option, but I think the key here is to try and prevent the use of high pressure where you're going to have aerosol introduced very easily. If you have good extraction in the room as well, which keeps levels of steam and aerosol down, you can use air disinfection, which is completely separate from fogging. So something like air specs, which can actually eradicate any microorganisms that are in the air or held within the air. So there are different methods. I mean, let's remember here that fogging is surface disinfection applied in a different way. So fogging, traditional fogging that we all know and you know we're all familiar with, is a different method of applying disinfectant to a surface. So it's fogging is not designed for air disinfection. You need a specific air disinfection system for that.
Thank you, Stephanie. And then I would choose one which is familiar to that. So what could be measures for the most common areas in my RTU food site to start reducing humidity? So this is a pain point, for example, in tunnel washers. What can I do about condensation? And that to you as well, Steph.
So does that mean how do we help prevent condensation?
So yes, it's about reducing humidity overall in ready-to-eat food site. That's how I interpret it.
Okay, so again, you know, to try and use the correct pressurized system, so 25 bar would be the top end of what we would recommend. There are some cases, because you're going to get more condensation with areas that we don't have good extraction in, or have very low ceilings, or are constantly using hot water. So for areas like tunnel washers, for example, you know, let's consider perhaps changing the chemistry to one that we can use at ambient temperatures, or you know, cold water, or even our foam type cleaners for our main hygiene clean. Let's consider different chemistry here where we can reduce the in-use temperature slightly. So, you know, we're not suggesting that we turn everything cold all the time, but there are areas, especially tunnel washers, where we can use products like Inspex 210 to replace the hot water disinfection part of a tunnel wash. And this is used in cold water, ambient water temperatures, and it completely reduces that condensation risk.
Okay, thank you, Steph. There's coming a question everybody on the chat. So what is the limit for the ATP swaps to be established? Adam, I will hand it to you.
Yeah. So generally the limit is actually based on the type of equipment that you have. So because RLU is the relative light unit, so it actually depends on the type of equipment that you have. So for example, the Neogen one or the Charm one, they can have different limits. In terms of identifying a limit in your facility, generally what the manufacturer will do is it'll give you a target baseline to start with. So, you know, for example, on some of the 3M ones, it can be 150 versus the Hygiena ones are more around 10 to 30, depending upon the surface and the food product. So you can actually have very different baseline numbers depending upon the type of equipment. And then the second part is really about the trending piece. So in order to set up your baseline, it's really important that you get a good sampling to start with. So you do the trend and you start with a trend. And then once you have this trend documented, then you're looking for shifts in the baseline. So if it starts to go up or it starts to go down, that can dictate what you should be doing differently, or you understand that something's going better than it traditionally was in the past.
Okay, there's a follow-up question from Ling Li. So she's asking then, thank you for the answer. And is there any reference data for the baseline limit setting?
Yeah, generally that should come from the equipment manufacturer. So I know, for example, Hygiena has on their website the actual baseline information, and it's divided by product type, and they'll actually give you the limits. So you should be able to actually get that from the manufacturer of your equipment.
All right, perfect, thank you. Then again, monitoring. For monitoring, check on Listeria monocytogenes or Listeria SP or both. Adam, that you as well.
Yeah. So generally what I've seen is people are for the environmental monitoring programs, they're targeting Listeria SPP, mainly because where you have Listeria SPP, it's a broader group and Listeria monocytogenes can grow. So I would always say that you should start with the SPP, and then if there's an example where you did it on a food contact surface, then at that point, then it would probably be worth going to the species level and understanding if it's Listeria monocytogenes or one of the other ones, because depending upon the country where you are, the limits also can be different.
Mm-hmm. And again, to monitoring, how often Listeria monitoring must be performed in areas where we have too many equipments and open plant cleaning is performed?
So if you're monitoring for open plant cleaning, when you want to do your verification activity to say your open plant cleaning was successful, you probably don't need to do as much monitoring for Listeria. So you can use other process parameters to show that your open plant cleaning was successful. For example, you can track time, temperature, concentration, frequency in between rinsing to help show and demonstrate that your open plant cleaning program was effective. So based on your validation, so you don't actually need to do direct testing for Listeria super frequently. If you're talking about monitoring for Listeria in relation to your environmental management program, it really is a decision by the facility. In most cases, depending upon the type of equipment, I've seen at least a monthly. It also depends, obviously, on the type of food being produced. But if you have, say, a medium risk food group with a fairly strong environmental management program, something more on the monthly frequency could be reasonable. But it really is dependent on the food being produced and the site's control measures that are in place.
All right. Thank you, Adam. And last but not least, the questions I can see here from the overall chat is, what are the most effective chemical substances to kill Listeria?
So,
all right, as you like.
so at least for me, this is a personal favorite subject. So we have in Europe the BPR, which dictates which microorganisms should be tested against the chemicals for the efficacy of the chemicals. In a lot of cases, Listeria is not on the list of the microorganisms that need to be tested. There are other microorganisms that are much more resistant and are harder to kill and require more concentration or more time in order to kill them with the appropriate log reduction. So when you look at the BPR regulations, a lot of times you'll see Pseudomonas or Bacillus, and these end up being in the same group and category as Listeria from a holistic standpoint. So as long as the product is registered with the BPR, then it will be effective against Listeria to the appropriate log reduction. I don't know if that makes sense, or Steph, you have something you think I should add?
No, that's perfectly clear, Adam. I mean, you're right. I mean, it's not that Listeria is hugely difficult to kill, and I mean, quats will kill it, diamines will kill it, chlorine will kill it, peracetic acid will kill it. It's all about the choosing the chemical for your regime as well. So it's about the methodology. So there's no point having a super sophisticated, really complex chemical if you're not applying it correctly at the right concentration on the right surfaces. So to me, methodology is just as, if not more important than the chemical selection. And as you said, Listeria compared to the standard test organisms that we test against is not the most difficult to kill.
No, but where it does become difficult, like you pointed out, is if you have hygienic design problems, you have harborage locations. It basically the thing that I love to say is, if you can't see it, you can't kill it. So it's really important that when you're doing your open plant cleaning process, that you can visualize the space and you're getting at all of these harborage locations. And that's one of the reasons drains is always such a hot topic, because it's really difficult to visualize a drain.
All right, perfect, thank you. So to finish off, as we are at the hour, there was one question remaining. So where do I get more in-depth information on hygienic design, and what is the best choice by type of object? What are the standards?
So the in Europe, generally what we use is the EHEDGE standard for hygienic design. And they actually just released a new standard maybe 6 months, a year ago-ish. So that standard is available and it's on the EHEDGE website. And I think that that's probably the nicest culmination of information. It's quite lengthy, but there's lots of interesting information. Thanks, Sandra.
Thank you. So I just wrote the abbreviation in the chat. Everybody can take this from here and put it onto a web browser. Thank you very much, everyone. So, as we said, this has been recorded, it's going to be shared with everyone. Thanks so much for your time and participation. And whenever you have another question, please feel free to reach out to us, and see you next time for the other food safety webinar. Thank you very much. Bye-bye.
Thank you.